everybody, and welcome to Azure Flash News. It is the 26th of July. Good morning, Tim.
Good morning, Mark.
This isn't Rick.
I am not Rick.
No, this is hello. Good morning, not Rick.
Yes, I'm Tim Sullivan.
Yeah, good. Yeah, Tim is. Well, why don't you introduce yourself a little bit? I know you've done this show before. But
yes, I have. But Tim Sullivan, I'm another cloud solution architect here at the Dyna MTC out of the Minneapolis office for Microsoft, working with customers on making sure they're successful with Azure.
Yeah, so great. It's good to have Tim here. And of course, I'm Mark Garner, so glad to be with you guys this morning. One thing I will say is, sorry we missed you last week. Sorry about that. We had a scheduling conflict with the MTC here, and so we didn't have a chance to get in the studio, but that's okay.
Yes. Yeah.
We'll catch it up this week. I went back and looked through the announcements from last week and pulled forward the important stuff, and we get some good stuff this week.
Yes,
so
we do.
Just as a quick thing, we're going to talk a little bit about one of the Microsoft teams and how they moved to Cosmos DB.
Yes.
We're going to talk a little bit about monitoring.
Sure. Yeah.
We'll leave it at that. And then we're going to talk about containers.
Yes.
For those of you who are using AKS and containers, we'll kind of talk a little about an open source connector.
Sure.
Connector to an open source ecosystem. Well, I'm being very obtuse, aren't I? And then we're going to talk about Azure Bastion. There's an article about it, but I think we can take a minute. Since we got Tim here, he's really strong in many things, including infrastructure. And so I thought we'd have Tim talk to us a little bit about, show us a little bit about Azure Bastion and kind of give us a little demo. So let's get back to it. Let's start with the Cosmos DB. Whoops, not that. Always goofing around here on my computer. All right. So there is an article, and you can catch the article in the show notes, about how one of our internal teams is making an effort to move from something that's deployed internally, like in your data center.
Yes.
To make it a cloud service.
Yes. And I think that this is another great case study out of our Cosmos DB product group, where they talk about how the Azure Advanced Threat Protection team took a service that was offered where you could install it in your data center, and it used MongoDB internally to get these threat analytics, and how they considered moving this to a cloud service, and what they all thought about as they were moving to Cosmos DB and the advantages that you get from using a first-party service like Cosmos DB.
Yeah, some of the reasons why this is not necessarily the list that they had, but some of the reasons why you might want to move to Cosmos DB for a service is, for instance, like it's globally distributed. It's easy to turn it on in another region. The SDK, the way you program it, automatically fails over to the correct region. It automatically directs reads to the closest read region and automatically directs writes to the writable region if you're in the single write mode. Yeah. So you could be, I think, matter of fact, they've even switched it to where the default, I think, is the default multiple region writes. I can't remember what they've left it at. But anyway,
I'm not sure either.
I can't remember. But, you can have multi-region write and read, and the SDK just automatically understands. So as a developer, you just don't have to worry about that, because I came from a SQL Server background, and back in the old days, not only did we use stone tablets and chisels, you had to actually put application intent equals read only in your SQL Server connection string.
Yeah.
So it just automatically happens. There's no indexing. There's a million reasons why Cosmos DB is such a great platform.
And one of the things that I really like about this article, Mark, is that they really walk through some of the considerations on how they're building out their collections, how they're assigning request units to those collections, and how they're thinking about their partitioning to make sure that the application performs both from a cost perspective as well as from that performance perspective that our customers expect from a solution like Advanced Threat Protection.
Yeah, and one of the things that I say to when I'm working with somebody is I say, the architecture is the price. The price is the architecture. It's the same thing. And so you, in the cloud at least, on-prem, you tend to oversize and build VMs, maybe a little too big, and then the VMware administrator is responsible for making sure that they allow oversubscription and that they manage at the host level. Yeah. So that's how that works. That's how you get density. But in the cloud, you pay for what you use. You pay for what you use.
Yeah,
There's nobody else sort of watching that. And so the application architects are determining the price of the solution. And so if you feel like it's worth it and you're going to store a ton of data and it's all a bunch of attachments, you wouldn't want to do that in binary in a Cosmos DB document.
Yes.
For instance. You'd want to do that on blob. So that's going to mean an application architecture change. So you really have to pay attention to how you design your collections and how you design your partitioning, because if you do design the wrong partitioning, it will cause extra RUs, or which is basically the unit of measure of performance in Cosmos DB.
Yeah.
You'll be using too many RUs and you'll be buying more than you really need.
Yeah, that's a great point, Mark. That's a really good point.
Yeah. What else did they say? I mean, they kind of said that, I mean, it makes complete sense. They talk a little bit about geo-replication. I'm sure that makes complete sense for these cloud services. I mean, you need to be able to run these things in a geo fashion. Like, you need to have multiple copies to provide the high availability that people need, the DR. Yeah. So, yeah, anything else to add?
No, I think that pretty much covers it.
Great, cool. Oh, one more thing. There is actually two articles in this series.
Yes.
There's more in the second article. So if you want to get a little bit more information about this case study, essentially, go check out the series. There's another one. Go check it out.
Yeah, definitely.
Yeah, okay. All right, so the next thing here is not really an announcement, and I guess that one wasn't really either, but it's about Azure Service Health and Azure Monitor.
Yeah. And what it really comes down to is talking about when to use which tool and how to know what each tool is telling you. And I think that that's an important consideration, you know, is that there's always so much going on, and a lot of times we get cloud architects and customers coming to us and saying, how do I know what's going on? And what Azure Service Health helps you to know is, am I affected by a problem in the Azure platform? Is there something going on in the Azure platform that's directly impacting me? And so Service Health will get you information about it's individualized to your subscriptions. And so it knows if you're impacted by something, whereas the status page, for instance, will tell you if there's a generalized issue or something along those lines, but it doesn't necessarily say, you know, we might not put up that there's an incident if it's just affecting, you know, a couple of virtual machines. But if you came in here and you were having a problem with a virtual machine, it might show in Service Health if your host is impacted or something along those lines.
Right. So the global view of Azure Health from a service point of view. So think about this as a pretty big view. Like you said, if there is a small problem, it is possible that we would not surface it to the Azure status page.
Yeah.
If you have a ticket, like for instance, if we get a ticket from somebody and they can't connect to their VM, we're not going to publish something to the Azure status page saying, Tim is having trouble getting to his VM, and it might be our problem. So you have to be aware of kind of the level of events that we publish there. But it is an important way to see and get transparency as to how we see the status of the Azure platform.
Yes. Yep.
Which is a little bit different than what the article is talking about. The article is really talking about the resource health. In other words, like just for you, are your VMs and that kind of stuff up? So this is kind of a corollary to that. But
and it's from that platform perspective for Service Health still, where it's these are things that are somewhat outside of your control. And so as you talk about that responsibility model and the shared responsibility in the cloud, Service Health is really getting to where you can see something that's, you know, impacting you, but outside of your control to an extent. Whereas Azure Monitor really drives towards your individual applications and the things that are inside of your control. So there you can start to look at your metrics on your VMs or your errors in your app services, for instance. You know, Azure Monitor has started to tie together all of our different tools to analyze and visualize and respond to events, allowing you to build that telemetry for yourself for the stuff that you are responsible for. And so that's what this article, I think, it really comes down to, is it does a good job of discussing how to think about, is it Azure or is it me? And you know, building out Azure Monitor is definitely going to be a skill set that you'll want to have on your team to make sure that you are able to know if it's you when something's going wrong.
And so is it Azure? That's Service Health, Resource Health. Is it me? That's Azure Monitor.
Yes.
And so Azure Monitor gives you the capabilities to look and see if your application is, like processing data. In other words, you see no throughput in your application. That could be a problem with Azure. It also could be that your application is throwing an exception on every single request.
Yes.
And nothing is happening. So, and that would be Azure Monitor for you to kind of be like, go to Resource Health and say, okay, there's no system-wide issue. Then you go to Azure Monitor to say, okay, I see no data flow, but I go into App Insights and I see that every single request to the API is throwing a internal server error.
Yeah,
or whatever.
that's a great example.
So you got to kind of use them both. And I don't know. I mean, I'm not sure if I have a suggestion on which one to check first. Probably it's not Azure.
Yes. Yeah.
Probably it's not Azure. So you probably should go to your application first. But you should always keep in mind that you should use the resource health. And you can also get alerted on both of them.
Yes. Yeah, definitely.
So don't forget about that. So don't forget that. And you'll need to be thinking about who needs to be alerted of resource health issues. So be thinking about, like, how do you want to actually, if we have a service outage in Azure and you don't yet see it in your application telemetry, although you should. If it affects you, I'm assuming you should see it in your telemetry. But how do you want to be alerted? Do you want just to alert like ServiceNow, or do you want to alert people, application teams? So just be thinking about that, because it's really important to be able to kind of understand how Azure has Fabric health, and then you have your own application health. Okay. All right. Okay, so I put these together because they were both Azure Monitor related.
Yeah, no, I think that it makes a lot of sense.
Kind of keep talking about Azure Monitor. So I think it's pretty, okay, so there's like 3 levels of monitoring going on in Kubernetes.
Yeah.
Okay, so there's the resource health, which we just talked about. We're going to mention it. Then there is the monitoring of your virtual machines.
Yes.
For AKS.
Yes.
How is my virtual machine performing? Kind of like, think of it like virtualization. From a virtualization point of view, like, are my hosts healthy? Are they out of memory? Are they out of CPU?
Yes.
But in addition to that, we need to monitor the containers.
Yes.
So this is about the container monitoring.
Yes. So Prometheus, as they say, so the actual announcement, I guess we should tell them.
Yeah.
For the people that aren't necessarily looking at the screen. This is an announcement. Yeah.
Yeah.
We now have a preview for monitoring your containers with Prometheus, which is an open source cloud native computing foundation tool.
Yep.
That provides a ton of telemetry and metrics on a Kubernetes instance. And what this is actually telling you, though, is that in the past, if you were going to use Prometheus for Kubernetes, you would have to set up a server with its own database, and you'd have to manage Kubernetes, or you'd have to manage your Prometheus server and all that stuff, in addition to all the other things that go into managing your Kubernetes environment. Well, now in Azure Monitor, you can just start to have your Prometheus, endpoints project telemetry into Azure Monitor, so you can use the same tool that you use for all of your other workloads while still getting all of that great information from Prometheus. And we take that, that's one of the things that I really like about Azure, is that we take away that no value work. Building the server for Prometheus doesn't actually give you the value of Prometheus. Prometheus is what gives you that value. And so when we take that onto ourselves, we're really offering you, I think, a great tool that you can easily take advantage of then.
So it looks to me like I was expecting that when I looked at this architecture diagram, I was expecting to see like a sidecar Prometheus, but I don't even see that. So it looks like the application pods can just export natively. And so like the article says, I guess I'm just sort of commenting, thinking out loud, there is no Prometheus needed.
Yeah.
Like you don't even need a sidecar, like nothing. These pods know how to export or how to expose in Prometheus endpoints to let you pull this telemetry, and you can pull it into log analytics here, using the log analytics agent, I guess is actually what we're talking about here, which runs, if I understand correctly, runs as a, what do you call that? It's 1 pod per node always. I can't remember what that thing is called. A daemon set. It's a daemon set in Kubernetes, a daemon set. And what that means is we always run 1 log analytics agent on every node, no more than 1. and it pulls all of the telemetry for each node, which is in turn pulling them all from all the pods. And I know that the log analytics agent has been around a while, and it was pretty basic when it came out.
Okay.
It was not that great.
Yeah.
There's been a lot of changes and improvements there. So if you haven't tried the log analytics agent for monitoring, you really should give it another try.
Mm-hmm. I think that if you scroll down a little bit further there, Mark, there's a great little chart here. Yeah, that's what I'm looking for.
Yeah.
Where it really talks about, out of the box, as you were saying, we're able to monitor your platform, which is the nodes, so the individual VMs that are running your pods. We're able to look at your container, so your Docker containers, which are running inside of those pods, the orchestrator, which is Kubernetes itself, out of the box with Azure Monitor.
Yeah.
And then what this is getting you, though, is when you start to look at your deployments, your jobs, your cron jobs, which are Kubernetes constructs, I guess might be a way of phrasing that.
Yep.
You get deeper insight into that you wouldn't get otherwise with Prometheus, which is why people had been deploying Prometheus servers before. So I think that this is a great little
this is awesome.
depiction.
So in other words, if you're using AKS or Kubernetes,
yeah,
you need to do this. You're probably using Prometheus already.
Yeah, and just take away that need to manage another server and get on, get onto Azure Monitor, and you're able to see everything all in one, because you're probably using Azure Monitor even so, whether you're using AKS or you set up your own Kubernetes instances, then you're probably using Azure Monitor to look at those underlying nodes, those underlying VMs to see that. So might as well have it all in one place where you can surface that all. So this is great, I think. Yeah. So
really awesome. We want to meet customers where they are, and if you want to use Prometheus, use it. That's great. And if you want to set up your own server, that's fine too, I guess. But if you don't, and you just want to use Prometheus as a telemetry generation strategy, do that and just pull it into our platform. Pull it into log analytics.
Yeah, it's all about the value that you get and being a real value add. Like I said, you're not getting the value out of running that server for yourself. You get the value out of what Prometheus provides you. So,
right.
Yeah.
Awesome. Okay, so this kind of brings us to the last announcement. It's sort of an announcement. It's probably an announcement for a lot of people because they probably haven't heard about it yet.
Yeah.
But this article is about a specific challenge with a service called Azure Bastion, and the challenge is using Azure Firewall. So we're going to back up for just a second, talk a little bit about Azure Bastion, what it is, how it works, and Tim's even going to go do a quick demo.
Yeah.
So do you want to talk about Azure Bastion, just like what it is? And
yeah, sure. So I'm sure that a lot of you, especially in the infrastructure space, are familiar with Bastion hosts, or jump boxes as they're also colloquially known, which is, for those of you who don't know, it's if I have virtual machines inside of a virtual network and I want to be able to remote desktop or SSH into those machines, I don't want to have a public endpoint or necessarily an endpoint that I can connect to from anywhere in the world, or even from on-prem to all of those individual machines, because that means that my surface for attack is much larger than it needs to be. And so what your security teams will often request, or your infrastructure teams, will be that we put in a Bastion host, which is another VM that's essentially your jump point where you come into that virtual network, and then that has access to all of those other machines, so they don't have to expose that port to the world or to a wider network than necessary.
So in other words, we reduce, so instead of having hundreds or thousands of virtual machines with RDP or SSH endpoints, we have one or maybe two or a few, according to scale, that have RDP. No, this is just regular Bastions, not Azure Bastion.
Yes.
That have, and so in other words, if you think somebody is messing around with your stuff through RDP, you can turn off access on these 2 or 3 machines rather than 2 or 3,000.
Exactly. Yeah. And so what we've done is similar to what we were just talking about with Prometheus, is that we have introduced a service that's in public preview now, called Azure Bastion service, and that is similar, where we're removing the need for you to build that VM and manage that VM. So you still deploy the service, the Bastion service, and it provisions it in a VNet still, but you no longer have to worry about patching that or worry about the security of that. We're handling the underlying instance that the Bastion service runs upon. So what I'm going to walk you through is that I've built this resource group, and in this resource group I have a Windows virtual machine with no public IP on it, and so I'll click into there in a second so you can see that. And so you can see these are just the typical resources that I get with a virtual machine and my VNet and my diagnostics. And then I've got these 2 resources which are necessary for the Bastion service. So I've got a Bastion called TJS Bastion 01.
And that's kind of the Bastion service instance. Like,
Yep.
that's what you see when you create a Bastion service.
Exactly. And then it has a public IP. Now, the only port that's open on this public IP, so you can see here we've got our public IP address assigned. The only port that's open is 443, so HTTPS, which is usually considered to be a better way of accessing lots of resources because we don't have to expose those known ports for RDP or SSH like you otherwise would.
Right.
And so then
in other words, port scanning won't find an RDP port open.
Exactly. Yeah.
Yep.
So this looks like any other web server out there.
Yep.
So you can see here then that I have this virtual machine. I'm running Windows Server 2019 Data Center, and you'll see I have no public IP address. I have a private IP address in a VNet, and the Bastion service exists in that same VNet.
So this is my workload virtual machine.
Yes, this could be anything. This could
a
be
web
an app
server
server, a web server. You know,
It's hosting it's hosting my internal expense report site. or
yeah.
whatever.
This could be Active Directory even. You know,
Okay,
and
an AD server.
Yeah, and we don't have to have it open. There's no externally accessible ports on this machine right now. But so then what I can do is very similarly to how you might be accustomed, is I just click my connect button, and then you'll see that in this preview mode I get a new tab
Option, yeah.
for Bastion. So for those of you who can't see the screen, when you click connect normally it gives you RDP or SSH, and it will download an RDP file or give you your SSH string that you'll need to put in to connect to this machine. What Bastion does is it just prompts me for my username and my password, and then I click connect, and what you'll see is we open up a new window. It's asking if I want to allow the clipboard, and inside of my web browser, this is what happens when we do a live demo. Let me try this again. Inside of the web browser, it will open a connection.
And I think that's an important thing to understand is that when you use the Bastion, you're not using RDP, the client. You're not using the RDP client. You're actually opening up a browser-based session across 443 to allow your access to this. It's kind of just a through. I'm trying to think of this, if the architecture is actually more of just a pass-through service, because we're not actually providing you a jump host that you have to remote desktop to another machine.
Correct. Yes.
We're actually providing you. Yeah. We're actually, and maybe this is where I was not understanding correctly, is I thought we were deploying some service that you remoted to that allowed you to remote. That's not how it works.
Yeah.
It's a pass-through service that's completely transparent to you, that you say, I want to remote that machine that has no public IP, and it opens up a pass-through service that allows you to remote directly to that machine using this Bastion service.
Yes. And so the nice thing about this is that what actually happens is inside of that VNet, it is using 3389 from the Bastion service to your VM. And so there's an NSG rule on your VM that says allow 3389 from my Bastion service.
Oh.
And so, but the Bastion service has 443 open to the outside world. So you go 443, and then it's using an internal route over 3389 still to get to this machine, or 22 in the case of SSH.
Okay.
But
So that was excellent. So for those of you who haven't had a chance yet to see Azure Bastion, that was a quick demo, which was awesome. A demo's worth 1,000 words. So if you're listening, if you're mowing the yard right now or whatever, later on, you can go to YouTube and watch the video, or if you, for the next week or so, you can go to our blog, and there's a link to the archive. You can watch the video there. Or for a little while, if you just click the join link for a few days, we leave it up for like 4 or 5 days. If you just click the join link in your browser, then it'll bring up the video.
Oh, great.
And if it's after about a week, then you'll have to go to one of the archive sources. So just for people to know, check YouTube, or check the website. So, okay. So that's awesome. So now we're back to this article.
Yes.
Not really an announcement. So what is the challenge? So we saw in your demo here, I'm gonna bring up that little demo. We had a VNet, and it had a subnet, right?
Yes.
No, it didn't.
It had 2 subnets.
It had 2 subnets.
Yep,
one subnet for your VM, for your workload, and one subnet for your Bastion.
Yes.
And that IP address for the Bastion was in that subnet, right?
I
guess it was just a public IP.
Yeah, it has a public IP, is what you're presented with. You carve out address space for the Azure Bastion subnet, so much like you would for your application gateways or things along those lines that require their own IP ranges. But you get a public IP actually on the Bastion service that has 443 open to the internet.
And this is a really great drawing. I think this actually draws everything. So what we're adding here is, what if you allow egress from your workload VMs, which they need, honestly. Almost always, these workload VMs need something from the internet. If they need to egress, but you say, okay, that's cool, except I'm going to put a route table on that workload VNet, and all of your egress has to go through Azure Firewall. What sort of extra challenges does that bring?
Well, so what we found is that, with this service in particular, is that you're forcing all that traffic through the Azure Firewall, or it could be, a checkpoint or a Cisco, any kind of firewall, and network virtual appliance.
Network virtual firewall, whatever.
And you have your default route going through that. What we see is that sometimes we get asymmetric routes then for a service like this, where this user-defined route is applied to the Bastion subnet. And what this really walks you through is, having to worry about how your RDP and SSH and all that stuff is working for ingress and egress with these NVAs.
Because the traffic that comes from you through the Azure portal, through Azure Bastion, and to your VM, that probably works fine. But then when the traffic comes back from your VM to Azure Bastion, if it routes that egress out through the firewall, no worky.
Well, yeah, and so what it's really saying is, just make sure that you're not putting that route table for Azure Bastion subnet. Because what you want to avoid is having the Azure Bastions at egress going through the firewall.
Because traffic that comes in through Azure Bastion and going out the firewall, the Azure portal or you says, I don't take traffic from where I didn't get it from.
Yeah, exactly.
Like that, I don't know what that traffic is.
Yes.
And so it just ignores it, and so you get, that's called asymmetric routing. What I think is, I just want to take a second and say, it's interesting to me. I think a lot of infrastructure people understand Bastions and stuff, but the reality is that more and more of the work of managing the quote infrastructure is landing in the laps of application developers. And so if you have an application and it uses mostly Azure PaaS services, but a few VMs, and you need to protect them, and you're kind of running this, you might end up running this network. You need to understand these things. It's pretty simple to set up. You can do it. And if you need a little help,
you know where to find us.
You know where to find us. You can actually, there we go, boom. Emily's on this. You can tweet us at Azure Flash News. That's a great way to get to us. It seems like maybe a no-brainer for people who do this all the time. And for those of you who are infrastructure folks out there listening, kind of going like, oh, okay, this is great, but like, I already knew all this. The fact of the matter is there's a lot of people who are picking this stuff up that have never done it before.
Great.
Okay, so that's that. So please don't put your default route to the Azure Fire or to the NVA on your Azure Bastion subnet.
Yes, exactly.
That's the lesson learned here. It must be happening a bunch for them to
make an article about it.
Make an article just about don't do that. Which I think once again goes back to tell you that there are people who don't normally manage networks and bastions and that kind of stuff that are doing this because more of the stuff is landing in their laps, which is okay. And so you can do it, I promise, because I'm one of those people. I'm not really an infrastructure person. It's an interesting time with more full stack infrastructure work. Like you have to kind of know the whole stack, including infrastructure. So anyway, all right. So if people want to find you after this and ask you a question about Azure Bastion or anything else, except for marriage. No, I'm just kidding. Just kidding. Where can people find you?
So you can reach me via email at sullivan.timothy@microsoft.com or
Sullivan.timothy?
Yeah, there's 3 of us, Tim Sullivans. I have a very common name at Microsoft, so I got the reverse name.
One. Oh, how about that? Okay.
And you can also find me on LinkedIn. So I'm Tim Sullivan, or TJ Sullivan 1 is my LinkedIn name. So feel free to reach out to me on there too.
But you could probably, I guess you could say Tim Sullivan Microsoft, but you might find the other 3 Tim Sullivans.
Yeah, I mean, and I'm sure that the guy from the Surface division or the guy from MCS would love to talk to you about Azure too.
No, sure, why not? And if you want to catch me, you can catch me on Twitter at mgarner is fine. Or you can email me mgarner@microsoft.com. It's totally fine. Don't forget to tweet us at Azure Flash News.
Yes.
And follow at Azure Flash News, please. Remember, we host the show at the MTC. We really appreciate all of their help, and thanks to Emily for producing the show. So thanks, Emily. And also, catch us on YouTube. We have the podcast on Stitcher and Google and Apple, and then also the websites. If you need to go catch an old show, please do that.
Yeah.
I think that's it.
Yeah.
I think that's it. So it's a great show today. Thank you very much for watching. We know that your time is very precious, and so we appreciate you carving out your time to catch us.
Yeah.
And so we'll see you next week.
Sounds good.
I think.
Yeah.
And
as Rick would say.
Yeah. Keep your hands on the keyboard. Your head in the cloud. Yeah. Thanks, everybody.
Thanks.
Have a good week.